Air is power. Air is dynamics. Air is music. Air is life. Clean air is a precious resource. Bosch gasoline direct injection was first used in the 1930s in aircraft engines. And in the 1950s, Mercedes' legendary Gullwing 300 SL was fitted with Bosch gasoline direct injection. However, this completely mechanical design limited improvements to fuel consumption and emission levels. Automobile engines require quickly varying power, and they have to operate as cleanly as possible while producing the minimum of pollutants. These requirements are very difficult to meet using traditional technologies. Every blacksmith knows that fire requires large amounts of oxygen to make iron glow hot. A sufficient air supply is just as important as the right amount of fuel. The right interaction of these two factors is critical. In the new gasoline direct injection systems, the fuel is injected directly into the combustion chamber. This is different than the commonly used manifold injection, where the fuel is injected into the intake manifold and is fed to the combustion chamber together with the intake air from outside. The required engine power is adjusted by precisely controlling the amount of intake air using a throttle valve. Due to the throttling at low engine torque, a considerable loss in performance occurs. Fuel consumption is not at its optimum. The new direct injection, on the other hand, injects the fuel straight into the combustion chamber. The required engine power is adjusted by precisely controlling the amount of fuel through the injector, directly into the combustion chamber. Through the recess in the piston surface, the fuel is then accurately directed towards the spark plug, creating an ignitable fuel-air mixture. A small ignitable cloud of fuel is surrounded by air. Precise air adjustment by way of a throttle device is no longer necessary at low torque, resulting in a more economical fuel consumption. The direct injection engine breathes freely. And this is how the system works. Through a high-pressure pump, the fuel is pumped from the tank into the fuel rail. The amount of fuel is controlled by magnetic valves which open and close within milliseconds. The entire engine management system is supported by numerous sensors and control elements. The heart of the system is the electronic control unit. Thanks to the high pressure generated by the pump and the precise arrangement of the high-pressure injectors, the fuel is injected into the combustion chamber with droplets which are much smaller than those of a domestic plant sprayer. A drop the size of a pinhead is turned into millions of tiny droplets. The research engine allows us to take a look at what is going on inside the combustion chamber. This testing rig keeps constant pressure and exactly defined conditions in the combustion chamber. As we can see, the shape of the spray stays constant. Direct injection opens up new opportunities in engine management systems. Depending on the demand of the driver, the electronic control unit determines the exact injection amount and timing. Varying amounts of power are required from the engine depending on the driving situation. In 70% of the normal driving cycle, Bosch Motronic allows the engine to work in its most economical mode. Direct injection minimizes the amount of fuel in each driving situation. The engine provides the power exactly when it is needed. By accurately controlling the fuel feed and combustion, fuel consumption and emission levels are kept low. Nitrogen oxide emissions are reduced considerably thanks to controlled exhaust gas recirculation. Bosch is working closely with nearly all European automobile manufacturers on the further development and application of gasoline direct injection engines. This involves specifically adapting the engine management functions and remaining system parameters to suit each type of vehicle. Engines fitted with Bosch direct injection systems react spontaneously to the setting of the accelerator pedal. They use up to 20% less fuel and produce 20% lower CO2 emissions. Industry has undertaken to reduce CO2 emissions by 25% by the year 2005 compared with 1990. Automobiles that run cleanly and economically today will reduce the burden on our environment tomorrow. Bosch is pointing the way into the next millennium.